In this quick video, we're going to be looking at the relationship between current, potential difference and resistance. Before we start looking at the relationship between these parts, let's first remind ourselves what the current is. The current is the flow of electrical charge. So what could this depend on? The current through a component depends on two things. Firstly, the resistance of the component, which is a measure of how easily the charge can flow. And secondly, the potential difference, which is a measure of the energy transferred to the charge carriers. These can be linked together in this equation. Potential difference, which is measured in volts, is calculated by multiplying the current in amps by the resistance in ohms. And this is an equation that you need to learn for your examinations. Looking at this equation, we can start to see the relationship between the potential difference, the current and the resistance. If we make the resistance bigger by making it harder for the charge to flow, then the current is going to decrease, assuming that the potential difference stays the same. Now let's look at the relationship in some circuit components. We're going to be looking at the relationship in fixed resistors, lamps and diodes. Firstly, we have a fixed resistor. A fixed resistor is also called an ohmic conductor. In these components, the current and the potential difference are directly proportional. So the graph will look like this, a straight line passing through the origin. This is only true if they're held at a constant temperature. Because current and potential difference are directly proportional, this means that the resistance will stay the same as the current changes. Now let's think about a lamp. A lamp also has a resistance, and this is why it can produce light. The filament inside acts with high resistance and it gets hotter as the current flows through due to the collisions between the moving charges and the metal ions in the wire. However, as a lamp works, the temperature goes up, and this has an effect on the relationship between the current and the potential difference. Here you can see that the graph is not directly proportional. The resistance of a lamp increases as the temperature of the filament increases, and this means that the current doesn't rise as high as it could, meaning the graph starts to level off, as you can see here. Finally, let's have a look at these. These are diodes and their difference to lamps. A diode has a high resistance in one direction, which means that the electricity can only flow through in one direction. Therefore, the graph will look like this. On one side, the current will be zero as it cannot flow, and then it will rapidly increase on the other, positive side. As well as knowing about resistance in lamps, ohmic conductors and diodes, you also need to know about the resistance in thermistors and LDRs. Thermistors are components whose resistance change according to temperature. As the temperature increases, the resistance decreases. This could be useful in situations where you want to control electrical circuits in response to changes in temperature. For example, they could be used in a thermostat to control the heating in a house. LDRs, as the name suggests, are components whose resistance change according to light. As the light intensity increases, the resistance of the LDR decreases. And this could be useful in situations where you want to control electrical circuits in response to changing light intensity. For example, LDRs could be used to switch on lights in a room when it gets dark.